No, I haven't. Why is that wrong? Because I've just said to you earlier that when we're using standard form, the number that we're multiplying, the 10 to the power of whatever, has to be between 1 and 10. Yeah? And 34 is bigger than 10. So that is wrong. How do I write that in standard form? I would write 3.4 times 10 to the power of 8. That is correct. Now, 34 times 10 to the power of 7 and 3.4 times 10 to the power of 8, they are actually both equal in value. But in standard form, it is 3.4. Okay? So they give you the same answer. 34 times 10 to the power of 7 will give you exactly the same answer as 3.4 times 10 to the power of 8, but we're using standard form. And so in standard form, the correct way to write it is 3.4 times 10 to the power of 8. So to finish, how do I write 87,000 in standard form? Well, it's 8.7 times 10,000, because 10,000 is 10 times 10, which is 100, times 10 is 1,000, times 10 is 10,000. So 87 written in standard form is 8.7 multiplied by 10 to the power of 4. So that's standard form. And I hope that's been helpful. And already there's a message to say that, you know, someone didn't understand about standard form and why you can't use 87 times something. So now this young person is going to go away and revise, refresh their memory, and then maybe they'll be able to answer questions if it comes up next week on paper 3. Okay, so that is what standard form is. Now, I've mentioned earlier that on today's paper we had trigonometry in a different way. Trigonometry is a big subject, it's a big topic, okay? And it comes up in different formats and different ways. Once again, maths leads and school head teachers have asked me just to revise the basic trigonometry, and then you as the year 11 pupil can then take away the bit of learning that I'm going to show you, and then you can develop it according to the level that you need to and that you are going to be doing. Because remember, there's 2 papers. You've got the foundation and you've got the higher tier. So there's two papers with the maths GCSE. So depending on which one you're doing, and if you are doing the first paper, the foundation, I encourage you, because I know you're going to do really well. Once you've done the first paper, the foundation, and you've got your good mark, go for the higher tier, because the difference between marks is not that much between foundation and higher. So push yourselves, basically. So trigonometry. What is trigonometry? Well, it was originally used by the Babylonians, but then it was the Greeks who took it on as being their creation. But it was originally used by the Babylonians thousands of years ago. And trigonometry is about the relationship between angles and side lengths within triangles. So where does the word trigonometry come from? Well, it's from the Greek. Trigonon in Greek means triangle, because tri in maths means 3, triple, and metron in Greek means measure. So you're calculating measurements to do with a triangle. Okay. Now trigonometry, it's usually the right angle triangle, but with higher tier, it's all triangles. Okay. So both foundation and higher tier, you both need to know and feel confident with trigonometry. So the trigonometry level that I'm going to do is in the middle. I'm going to sort of place myself. I'm going to aim in the middle. Okay. So imagine you've got a right angle triangle, because I did mention that trigonometry is predominantly to do with the right angle triangle. However, at higher tier, it's to do with all triangles. So that has to be made clear. So trigonometry, we've got the right angle triangle. So I've got a right angle triangle in front of me, okay? And my right angle is on the left-hand side. So the slope, the diagonal line, is going from the top down towards the right. So I'm trying to create a picture of the triangle that I have got in front of me. So the triangle that I have got, the right angle is on the right, and then the pointed bit for the slope is on the left, okay? Right, so I've got my right angle, and I've got a little square to show it's a right angle. So that's my right angle triangle that I've got. I've also got an angle in the bottom left, which is X. I don't know what the value of the angle is, but I've just called it X, okay? But what I want to do is just to make sure that you know what the three sides, how you recognize them and what you call them. We'll start off with the hypotenuse. The hypotenuse is always the longest side on the right angle triangle. It's always the longest side, and it's always opposite the right angle. So the hypotenuse is always the longest side, and it's always opposite the right angle. So as I've just said to you, my triangle, if I've got my right angle in the bottom left-hand side, then the slope, the diagonal line for the hypotenuse is opposite. You can then work out what my triangle looks like. Now, because I've given my angle X, which is I've put it into the bottom right, my angle X, opposite my angle, I've got a vertical line. So opposite my unknown angle X, I've got a straight line, a vertical line, and that is what we call the opposite side in my question. So that's the opposite side to the angle, okay? So it's opposite to the angle that we've got in question. And then adjacent, I say to you in the English language, if you sit adjacent to someone, you're sitting next to them. So the side that is adjacent to the angle X is what we call the adjacent side. So we've got the hypotenuse, we've got opposite, and we've got adjacent. And that's because I put my angle to be found in the bottom right-hand side of my triangle. Trigonometry uses three ratios, three relationships. We've got sine, cosine, and tangent. And they can be shortened to sine, S-I-N, cos, C-O-S, and tan, T-A-N. So if my angle is, as I've said, angle X, which is in the bottom right of the triangle, so sine of X, I would use the ratio opposite over hypotenuse, okay? Because sine is opposite and hypotenuse, cosine is adjacent and hypotenuse, and tangent is opposite and adjacent. So sine of X is opposite and hypotenuse, cosine of angle X would be adjacent divided by hypotenuse, and tan of X would be opposite divided by adjacent. So they are the three ratios that I would use if I've got my letter X in my right angle triangle and we're trying to work out the missing angle. So that's what we need to know. Now, trigonometry, we can use it to calculate the length of one of the sides. Okay, so we want to calculate the length of one of the sides. So let's keep the same triangle that I've just described to you, okay? Right, I'm going to tell you that I've got, where I had the letter X, that angle there is 32 degrees. So I've got my right angle triangle. My right angle is to the right. I've got my 32 degrees, which is on the right. So I've got my vertical line, the right angle, and I've got my diagonal line, which is the hypotenuse. And so I've got my right angle triangle. So I've got my angle as 32 degrees. I'm going to label my triangle. I'm going to say that where the right angle is A, B is the top of the vertical, and then C is the end of the diagonal line for the hypotenuse. So A, B, and C. Okay, right. And we want to calculate the length of AB, which is opposite. So AB is opposite angle 32 degrees. To be able to do that, you must know at least one angle and one other side length. Okay, so I'm going to use sine because sine of X, sine of 32 degrees uses opposite, which is the line, the side that we're trying to work out, and the hypotenuse, which is the length that we know. So sine of X, so sine of 32 degrees is equal to opposite, I'm going to say is O divided by 8, which is the hypotenuse. Now, I can now rearrange that mathematical equation that I've just written. I can now rearrange it so that I want to make the opposite side the subject of that equation. When we talk about rearranging and making X the subject, we're doing that now with our trigonometry. So now, because I want to work out the length of AB, I'm going to have AB, which is opposite angle 32 degrees. AB is equal to 8 multiplied by sine 32. On your calculators, I've been using a range of calculators. They're all scientific. You'll be able to work out sine of 32 degrees, and then you multiply that by 8, and then you will get the answer of 4.2 centimeters. Okay, so 8 multiplied by sine 32 is 4.2 centimeters. So therefore, that line opposite is 4.2 centimeters. Now, when I'm working with teachers, I always encourage my secondary school teachers to do what is called completing the triangle. And that means you're going to work out all the 3 missing angles and all the 3 side lengths. So at the moment now, we've got one angle that is 32 degrees. We've got one that is 90. We can then work out the 3rd missing angle, because angles in a triangle add up to 180 degrees. So there we're going to have our 3 angles. And because we know that our hypotenuse is 8 centimeters, we know that the side opposite the 32 degrees is now 4.2. We can use Pythagoras to work out the missing side, which is the adjacent to 32 degrees. So this is where maths becomes so exciting. And in my leaflet about today, promoting today, I did put there, maths is exciting. So we've worked out the missing side length using trigonometry. Brilliant, fantastic. We can also use trigonometry. Oh, thank you for the, okay. Yeah, this is from a teacher, okay, who's just asked me to mention, oh, okay, to mention Pythagoras. Okay, I will do that. No, I will do that. So she's asked me just to go over Pythagoras because some students might not remember. So that is on my list. And in fact, I'll do it after for you. Thank you. Thank you, Miss So-and-so. Right, so we can also use trigonometry to calculate missing angles, okay? Right, to be able to do that, we need to know two side lengths. And then once we know the 2 side lengths, we can use them to decide which of the 3 ratios, sine, cosine, or tangent, we're going to use to help us to work out the angle that we want to calculate. Okay, so in my new triangle, well, actually, no, it's the same triangle that we've been using. So the triangle that I've been using, I've got X, which is the angle that we're trying to work out in the same place as it was before. That's the one we're going to work out. The opposite side is 5 centimeters, and the adjacent side is 7 centimeters. Okay, so we're trying to calculate the size of angle X using trigonometry, and we know 2 side lengths. We know the length of the side opposite the angle that we're trying to find, and we know the length of the side that is adjacent to the angle that we're trying to find as well. So if I'm using opposite and adjacent, if I go back to the ratios, I'm going to use trigonometry. I'm going to use tan, okay? So I'm going to have tan of X, because that's the angle we're trying to work out. I'm going to have tan of X is equal to opposite divided by adjacent. Opposite divided by adjacent. So tan of X is equal to 5, which is the side opposite, divided by 7. So how do I get the answer? Now, this is where students become a little bit confused. And I do understand when you're under pressure, there's nerves. Remember, you need to use the tan -1 button, because you're doing the opposite of the side lengths, okay? So it's the tan -1 button. So we're trying to find angle X, so I'm going to say angle X is equal to tan -1, 5 divided by 7. Now, with the scientific calculators, you can just plug in that information, And then the answer would come up as x, the angle, is equal to 35.5 degrees. So once again, completing the triangle, once you know you've got your right angle, which is 90 degrees, you've then got your missing x angle, which is 35.5 degrees. You can then complete the angles in the triangle because they must add up to 180 degrees, and you can complete the triangle with the missing side lengths, the hypotenuse you can do using Pythagoras, and then you can work out the missing angle. Once again, isn't maths amazing? Yeah, I'm smiling because there's always something that you can hang on to, something that is tangible. There's that word again, something that is tangible, something that you can hold on to, something that is next to you. That is, this is tangible, adjacent and tangible. Lovely two words there. Pythagoras, just because the teacher has sent me a message about Pythagoras. Right. Pythagoras' theorem: in any right angle triangle, the square of the length of the hypotenuse, which is the longest side, the square of the length of the hypotenuse is equal to the sum. And in mathematics, remember the word sum, S-U-M, means you add. So we're going to start again. In the right angle triangle, the square of the length of the hypotenuse, which is the longest side, is always equal to the sum of the squares of the lengths of the other two sides. Hence, we get that famous equation, a squared plus b squared is equal to c squared. Now, the way that I've always taught it is a squared plus b squared is equal to the square root of c squared. Because once you've got c squared, you then have to do the square root. And by me putting in that square root symbol at the beginning, it reminds students that they have to get the square root of that number. So in my triangle, it's the same looking triangle. The right angle is on the left-hand side, and then you've got the hypotenuse that slopes from the top to the right. And so I'm going to say that you've got A, B, and C. Okay, C is always going to be the hypotenuse. You've got A, which I'm going to say is on the left-hand side, the vertical, and side B is the horizontal, just for the sake of the question. So a squared plus b squared is equal to the square root of c squared. So A is 3 centimeters long and B is 4 centimeters long. I've just made up these numbers, okay? So a squared plus b squared is equal to c squared square root. Right, so we've got 3 squared plus 4 squared is equal to c squared, and then we have to do the square root, yeah? So 3 squared is 9, 4 squared is 16, and that equals c squared. So 9 plus 16 is 25. So 25 is equal to c squared. And so I'm going to rearrange. See, once again, rearranging. So c is equal to the square root of 25. And the square root of 25 is 5. So c, which is the hypotenuse and the longest side, is equal to 5 centimeters. And 5 centimeters is bigger than 4, is also bigger than 3. So I've used Pythagoras to calculate the missing side length in the right angle triangle. Now, these 3 numbers that I've just called out to you are special because we have what is called Pythagorean triples. We have what we call Pythagorean triples. And that is triangles that have got specific certain side length measurements. And I've just given you one, which was 3, 4, and 5. There's another 2, and that one is 5, 12, and 13. And then the third one is 8, 15, and 17. They are what we call Pythagorean triples. And so imagine you've got a question. Now, this is why I'm telling you this. Imagine you see a question and you've got 5 and 13 as part of the sides. You know that the other missing side length is going to be 12. That is usually what's going to happen because they are what we call Pythagorean triples. Yeah? So remember them: 3, 4, 5, 5, 12, and 13, and 8, 15, and 17. Yeah? Pythagorean triples. You heard it first with Mr. Numbervator on the math show on Chalk Hill Community Radio Station. Let's talk money. Let's talk money. And my next topic, a message. My next topic is compound. That's just from that's from a pupil just asking about if I'm going to be covering circles, which I am. Right. So compound interest. Compound interest. Compound interest is basically interest on top of interest. So you're getting interest on top of the interest that you have accrued, that you have built up from previous time periods, okay? So compound interest is really interest on top of interest, yeah? Compound interest is calculated on the principal amount of money. So principal amount basically means the original amount that you started off with, okay? And so it's calculated on the principal amount and the interest that you have already accumulated from previous time periods. That's what is the difference between compound interest and simple interest, which is annual. You invest and then you go. So that's the difference between compound and simple interest. So let me give you an example. I've got an example that I've made up here. I've got £100 in my account, okay? And I've been told by the bank that the interest rate is 10%. And I want to invest it in the compound interest rate account, okay? Now, the value of my money in my account will increase by 10%. I will have 10% at the end of year one. So at the end of year one, I have got £110 because 10% of 100 is a 10. So add it to the £100, I've got £110. So I'm going to start year two with £110. But I'm going to get 10% of 110, not 10% of 100, which is the simple interest. I'm going to get 10% of £110. That means I've got an extra £11 because 10% of £110 is £11. So at the end of year two, I've now got £121. Can you see how compound interest can greatly accelerate the way that your money grows? And this is how celebrities and people who have got lots of money, this is how they invest their money in compound interest accounts. And I always tell young people, invest in compound interest accounts, however big or small, because at a young age, your money will greatly increase in a short amount of time. Now, there's a formula that we can use to help us get the answer a lot quicker than doing it year by year. Okay, so I'm going to read out the formula. Get your pencil or pen ready. I'm going to read it out twice, and then I'm going to explain to you all the letters and numbers mean. So the compound interest formula is A equals P, open bracket, 1 plus R over 100, close bracket, to the power of N. Let me say that again. The formula for compound interest calculation. A is equal to P, open bracket, 1 plus R over 100, close bracket, to the power of N. Let's break up the formula. A is the final amount that you are going to get. That's what you have. That's what you're going to get. That's the money that you're going to get. Yeah, A. P is the original principal amount. R is the rate of interest over a given period. And N, which was outside of the bracket, is the number of times the interest rate is applied to your amount of money. Because sometimes it can be applied 2 or 3 times in the year, depending on the account. So let me say it again. A is equal to P, open bracket, 1 plus R over 100, close bracket, to the power of N. A is the final amount. P is the original principal amount. R is the rate of interest over your given period of time. And N is the number of times the interest rate is applied to the money in your account. Once again, remember what I said. Today's lesson is about me opening up areas that you might be weak on, but then you've got the next following 7 days to catch up on with it, you see. So that's the aim of this show. And so far, you have been brilliant. So far, you have been absolutely brilliant, okay? Before we go for our quick, short ad break, I just want to, I've got an old paper three, math paper three here. I just want to run through some of the questions just to give you an idea of what you can expect. I am not saying that these are the questions because I do not know what the questions are going to be. And to be honest with you, that's what the excitement of doing an exam is. You don't know until you open the paper. But what you can do is prepare for all eventualities. So one of the questions was make X the subject of the formula. A lovely, typical GCSE question. Making X the subject of the formula. And when you make something the subject of the formula in English, you're making that person or that thing the most important part of the sentence. In mathematics, it's exactly the same thing. Okay, so the question was R equals 6x subtract 7. That's what the question, and so it's asking you to make X. Oh, it's S making S the subject of that equation. So it was R is equal to 6x subtract 7. My eyesight. Another one is to do with ratio, which is one of my favorite topics as well. It's to do with ratio, and they give you an amount of money. You've got to share it in a particular ratio. A ratio is to do with amounts and it's to do with parts of a whole. We've got another question here to do with going on holiday, and they want to know how many people went somewhere or did something. Lovely questions. Traveling and measurements. You've got speed and you've got miles per hour. You've got to use that equation and the formula. You've got another one which is probability. Another one that is one of my favorites is similar triangles. Similar triangles, because similar triangles is easy. Okay, similar triangles are easy. Similar triangles have the angles in the same place. So both angles, everything is in the same place basically. But one triangle will be bigger than the other. But everything will be in the same place. Okay, so if you've got a small triangle, and one side is 5 centimeters and the other side is 6 centimeters. And then you've got a bigger triangle and the same side that was 5 is now 30 and the same side that was 6 is something. It's asking you to work out the missing side lengths. Well, if I know that one side was 5 and now it is 30, what do I do to get from 5 to 30? I times it by 6. Okay, or I can divide it by 5. Whatever way it is, yeah? But then, so because they're similar, I can now say that the side that was 5 is equivalent to 30 degrees for the bigger triangle. Then I can work out the side at the bottom and then the other missing side because they are what we call similar triangles. So that comes up quite a lot. So make sure you understand about similar triangles. Changing millimeters to centimeters, changing millimeters cubed to centimeters cubed. That's a bit more challenging. There's one to do with money, going shopping, work out the mean cost of shopping. Actually, the mean came up today, didn't it? But it came up, I'm just reading my list here. But yeah, it came up to do with factors from a list. But mean, as you know, is really, really important. Right, listen, we're going to go for a quick short ad break. When we come back from the ad break, I'm going to be looking at stem and leaf, capture, recapture, expanding brackets. If there's time, we're going to look at circles, arcs and sectors, and hopefully circle theorems. And then we'll go through a couple of more questions just to finish off the show. But listen, well done to everyone. Don't go too far. Quick glass of water. See you shortly.
and those with babies and young children, there's help with parenting, breastfeeding, plus support for parents or carers to manage their own well-being. With 8 family wellbeing centres across Brent, there's a local one near you, and they are your family's open door to meet professionals who can support you, like health visitors, maternity services, and breastfeeding clinics. Family Wellbeing Centres offer a wide range of free health education and welfare services to families and aim to give everyone in Brent the best possible start in life. Find out more about the support they can give you and your family on our website at www.brent.gov.uk/family wellbeing centres.
Job Hill Radio.
Go to www.sovereigncomics.co.uk and get your latest issue of Mr. Numbervator's Maths comic book series today. You are now tuned into the Mr. Numbervator show every Wednesday from 5:30 to 6:30 p.m. on Chalk Hill Community Radio Station. Let's get mathematical. Welcome back after that short ad break. And today's show is about preparation for paper 3 for GCSE math students on Chalk Hill Community Radio Station. And it's me, Mr. Numbervator, on the math show, which is every Wednesday between the hour of 5:30 and 6:30. Now I say 6:30, we need a lot longer than 6:30, but do you know what? If it's 6:30, it's 6:30. I had a request that was sent to me during the break. Now, if there's a topic or there are topics that you would like me to have a radio show about between now and next Wednesday, so this is the offer that we're putting out from Chalk Hill Community Radio Station. If there's a topic or topics that you would like me to go through in a bit more detail, then you have to let me know. And then if the demand is there, then I will beg Chalk Hill Community Radio Station, but they will give it to me because it's for you. And then we can have an extra show that we can actually have some more learning between now and next Wednesday. So if you're up for that, you need to let me know. You know what to do. The number is 07535 644850, 07535 644850, or sovereigncomics.co.uk, sovereign as in SOVEREIGNCOMICS, all one word, sovereigncomics.co.uk, or Dr_knows_it, NOSEZIT @hotmail.com. So you've got 3 ways of getting in touch with me, and we can see what we can do, because there's just not enough time to get through everything that I've got planned that the head teachers and maths leads and subject leads were asking me to do. So I'm going to try and run through as quickly as I can, but without compromising on the key knowledge and information. Stem and leaf, okay? That's another prediction of mine. Stem and leaf is another prediction of mine because box plots came up, okay? Stem and leaf is one of those topics that they can just throw in at random. So what is stem and leaf? It's a diagram, okay? It's another way of showing information and data, basically, okay? Representing, that's the word. So it's a method of organizing numerical data, but on the place value of the numbers. See, this is the difference, okay? It's to do with the place value of the numbers. That's how the numerical data is organized. So each number, when we're using stem and leaf, each number is split into 2 parts, and hence you've got stem and leaf, yeah? So if you've got a number, so for example, I've got 154. I've just made the number 154, yeah? The first digit or digits, and then you've got the last digit. So in my number 154, I've got the 15, the 1 and the 5, and then I've got the 4 because that's the last digit, okay? So the first digit or digits is what we call the stem, and then the last digit is the leaf, and it's only a single digit because the word digit means it has to be single. And that's the difference between numbers and digits. That's why I'm always going on about use the correct terminology, okay? It's the first 2 digits and the last digit. Okay, so in the number 154, the 1 and the 5, 15 is the stem, and then you've got the 4, which is the leaf. And that is how you would record, that is how you would organize the numerical data. You need to have your key, and then you can then interpret what that data shows you. And you can use it to calculate averages like mean, mode, and median. You can do all of that using stem and leaf. So if you're not too sure about stem and leaf, swat up on it. That means revise it, go over it, make sure you're comfortable, make sure you're confident. But that's another prediction of mine. It might be there, it might not be there, I don't know. But that's another prediction of mine, stem and leaf. Okay, brilliant. Someone asked, a teacher asked about capture and recapture. So on my maths show, I get people sending me messages about, oh, Mr. Numbervator, can you do this? Can you do that? I can't do everything on the maths show because there's just not enough time. So maybe in the future, we might have to have more than one maths show a week, which would be absolutely amazing. Capture and recapture. So capture and recapture. So let me explain about capture and recapture, and then you might know about it. You might know it already, but I'm just going to talk about it just so that I know that the person who asked me, I've been seen to be responding to their request. So it's a sampling technique used to estimate population size, the total amount of something, yeah? So let's just say I'm going to set up a controlled investigation, and the objects are going to be part of the population that I'm going to be talking about, yeah? And it's usually to do with animal. It's usually to do with animal population. That's when we have capture and recapture, yeah? So these objects have been captured, marked, and released. Then they're recaptured after a period of time. Can you see the reason why we're talking about animals and it's that sort of thing? Because you can't obviously capture a human being, mark them, then release them. So let's just say, so I've just said I'm talking about animals on the farm. Okay, I know some of you are going to say Animal Farm, George Orwell, but animals on the farm. Yeah, right. So these objects have been captured, they've been marked, so we know who they identified, and then they've been released. Then they've been recaptured after a period of time to see the change in how many have moved on and so on. The proportion of the marked number in the second sample gives us an estimate as to the population size. Isn't that interesting? The proportion of the marked numbers in the second sample, because it's been recaptured, that gives us an indication to the population size. And once again, there's a formula, and the formula is M over N, M for mother, N for November, M divided by N is equal to R divided by T. So M over N is equal to R divided by T. M is the total marked objects. N is the total population that we're trying to work out. R is the number of the marked objects that have been recaptured. And T is the total recaptured on the second visit. So we can rearrange that MN equal to RT. We can rearrange it to N, which is the total population that we're trying to work out, is equal to MT over R. N is equal to MT divided by R. So here's a little story. Here's a little situation that I made up. Okay, right. A farmer wants to calculate the number of cows that he has seen on an isolated wild farm. Okay, right. So what the farmer does is catches 12 cows, and they are counted 12. They are marked, and then they are released. Okay, so this farmer has caught 12 cows, counted them to make sure there's 12, marked them so he can identify them, and then they've been released. 5 days later, he catches 14 cows. 7 of those have been marked from the previous capture. Okay, so 7 of those have been marked, have been from the previous capture. The cows were then released. Estimate the total size of cows, i.e. the population, which is the letter N. So to use my equation, M is equal to 12. That was the total of 12 cows that were marked on the first capture. R, which is 7, is the total marked on the second capture. T is 14, which is the total captured on the second capture. So N is equal to 12 multiplied by 14 divided by 4, and that equals 24. So that's the estimate for the population of cows on the farm. So the farmer is basically saying that that there could be a population size of 24 cows on that isolated wild farm that that the farmer has seen. Okay, so that's capture and recapture. Once again, you know, look it up, go through it again. I'm just doing topics that, you know, oh gosh, the time's gone really quickly. I'm just doing topics that are very popular. Expand and simplify. Make sure that you're able to expand and simplify single brackets, double brackets, and triple brackets. So single brackets is like 3 open bracket 2x plus 5, and that would give you 6x plus 15. So when you expand, it means you get rid of the brackets. You multiply out to get rid of the brackets. That's what expand means in maths. And simplify means you collate like with like, okay? Like with like. Double brackets, if I've got x plus 4 in one bracket, x plus 6 in another bracket, I'm going to multiply everything in my first bracket by everything in my second bracket. Triple brackets, if I've got 2x plus 3 in one bracket, x plus 6 in another, x minus 4 in a third, I need to do the first 2 brackets first, expand and simplify. Once I've got the simplified version, I can then put that into a bracket and then bring the other third bracket down, do the same thing as you would with double brackets, and then you're going to get your final answer. Circle theorem. Just make sure you know about the alternate segment theorem and circle theorem. Angles at the center. The angle at the center is twice the angle at the circumference. You've got angles in a semicircle, angles in the same segment. You've got the chords of a circle. My favorite one is cyclic, as some people call it cyclic, but cyclic quadrilateral. The opposite sides in a cyclic quadrilateral always equal 180. And then you've got the last one, which is to do with the tangent of a circle. And then you've got, with circles again, you've got the arcs and the sectors of a circle. The arc of a circle is the portion, is the part of the circle, of the circle's circumference. The sector, that is like a pizza slice, okay? It's enclosed by 2 radii, 2 radiuses, yeah? So it's like a slice of a pizza, it's a sector, not a segment, not a piece, it's a sector. You might be asked to calculate the arc length, and you do that by doing the angle out of 360 multiplied by the circumference. Circumference is pi d. To work out the circumference, you multiply pi 3.14 by the diameter, which is what you'll be able to work out. To work out the sector area, it's the angle divided by 360 multiplied by the area of the circle. When you're working out the area of the circle, we use the formula pi r squared. For example, a circle has a radius of 10 centimeters and a sector with an angle of 60 degrees. It's asking you to work out the arc length and the sector area using what I've just told you. The arc length would work out as 10.47 centimeters, and then the sector area would work out as 52.36 centimeters squared. Please remember to have calculators in your degree mode, not the rads mode. It must be degree mode if you're working with degrees. Very quickly, just to go back to the paper, we've got here integers, simplify and expand fully. We've got angles, we've got percentage increase and decrease, we've got probability and ratio using marbles, we've got equations of a curve, we've got identifying parabolas and different curves that are represented. We have got, we have got another one to do with angles and direction. So this is quite a nice paper. We've got a heptagon, which is a seven-sided shape, and to do with angles. Listen, well done to all of you who did your paper 2 today. I know you've done well. I don't need to be told. I just know you've done well because you've had great teachers, great teaching, and you've got the support of your families and, of course, me on the math show. Paper 3 is next Wednesday, the 11th of June. If you need more help and direction, you know what to do. sovereigncomics.co.uk, Dr_knows it, NOSEZIT @hotmail.co. Doctor is DR. I'm not a doctor, but that's my name. And then the number to call in is 07535644850. Have a great week. Well done. I look forward to seeing you all next week, Wednesday, on the Math Show. Thank you. Bye.